Well, I'm going to discuss a little bit of a different perspective of the same problem that I'm extremely worried about, collapses, and how we do with infrastructure. Like it was mentioned before, we have this great word international. American codes are international. Only used in the US, but it's international. So when Congress decided that there were too many codes in the US, they talked to the companies who made the different codes and say, either you organize yourself or I'll do it for you. So in the fear of Congress doing the building codes, the International Building Code Society was made. And that's the codes we have now. And basically, materials associations like ACI and engineering associations like American Society of Civil Engineers, they keep improving from what's going on with research and experiences, new material for improving the codes. Now ACI is working on 318.25, and we just got 318.19 the other day. So I'm going to make a minimum reference to 318.19. I think it's a wonderful code, the best 318 there's been ever. It was a wonderful edition of 318. And recently we got a ASCE 722. ASCE 7 is a famous code in the United States and in many parts of the world, and determining loads for structures, not only gravitary, but earthquakes, wind, hurricanes, etc. And for example, the 318.19 code was extremely influenced by the Chilean earthquake of 2010. That was a major earthquake. We can see a building that had only 3 years in construction. It failed, it broke. Is there a pointer here?
Pretty weak later.
Huh?
It's a pretty weak later.
Well, I'll try to point it out anyhow. You can see on this side, the bases of the wall, they break down and the building fall, okay, during the shaking of the building. Why it's important? Because most of the advance on shear wall design for earthquake buildings started with Chilean 1985 earthquake. And studies made by Dr. Sharon Wood and other engineers, Viña del Mar earthquake, improved the US design on earthquake for shear walls. The Chileans has an extraordinary engineering force. They're good designers. We can see this failure, but only 1% of the buildings fail, and that's pretty low. For an earthquake that was 8.9, and the strong motion lasted 90 seconds, 9-0. It's not like the Caribbean earthquake of 7 seconds strong motion. This is 90 seconds. That's a world of rocking for a structure. So, and only 1% of buildings fail. So I want to say that in behalf of engineering designers. But this building collapsed. There was a big fight when the 318 keep changing the requirements for shear walls. It failed. The Chileans said that American codes were exaggerating what's needed to be done with walls, and that's the result. So Chileans changed their code, but it was such a good laboratory, the experience from the Chilean earthquake, that many universities in the United States performed research after the Chilean earthquake to see how to improve and avoid building failures. There was people sleeping there, that failure. So it's different from the recent collapse, but it's there. So all these changes are up to 318.19. What important to stress out that all this experience of big hurricanes, big earthquakes teaches us a lot of lessons, promote research and make changes. So not only Chileans went back to follow ACI 318 recommendation, but 318 changed itself and evolved, and they changed the hooks instead of 135 and the other 90 degrees. Both are now 135. And particular attention was taken into the hinge of the structure. It was always assumed for other experiences that it was very close to the ground. the Chilean experience, they were almost 2/3 height of the first level. So reinforcement had to change to recognizing that the hinges occur in other places that they were originally assumed. So that's a good learning experience. We learn from that, we improve the codes, and ACI and other institutions do that. And in terms of hurricane forces, in Florida, I'm Spanish. In Florida, the Miami-Dade County is a great code after the big hurricanes change as a standard to many areas in the United States and in the world for impacts during hurricanes, etc. So that's improving for new structures. And when I first started as an engineer, I was thin and I had a lot of hair at that time. The code requirement for wind design was about 5-page long. Now you take ASC 7, it's a whole book in itself just to try to calculate what is the corner force here. It could take you forever to do it. But what I want to say with that is that research has been done, has improved, and the performance of structures are significantly better, so they can withstand a great hurricane. So again, learning is a process. We learn, we do. We learn, we improve the codes. That's what it is. My nightmare are tornadoes. And last week there was one in New Orleans, which is not a place for tornadoes, but it was. And you know what terrifies me about tornadoes? ASC 7 has nothing on tornadoes, just a reference in the commentary. IBC has nothing on tornadoes, just a reference of this map. Nothing is done in the United States to fight tornadoes, to help people defend from tornadoes. And you see the darker maps, this is from IBC, is the pressure that should be the wind forces that we should design to provide a safety room for a house, a safety room. But what happened with the hospitals and the schools that exist in those areas? They're blown away every time a tornado comes. And nothing is done with tornadoes. Okay, so I think that the United States, to prevent collapses and full failures, in addition to work with earthquake and hurricanes, really have to pay attention to tornadoes. It's expensive to deal with it? Yes, it is. But we're supposed to be here for providing life safety to people, to be able to survive these great events. And there's been, in the early 20th centuries, there were tornadoes that thousands of people died. Now structures are much better, but still a lot of families get without homes, communities get out without hospitals, all because these tornadoes are hanging around and we don't pay attention, and the codes neither. So we need to learn from these disasters, and the engineering community and the universities have been doing a great job, except for tornadoes, in terms of learning and improving. Yet, the government or communities are completely blindfolded to existing structures. And we're talking about existing buildings. We improve for the next building, and what happens to the one that exists already? Who is going to pay attention to them? Recent disaster, what's going to happen with the buildings next to it? Are we really improving to do what to do with them? So we fortified new structures, but then what happened with the neighbors of those structures that may fail too and damage our new structures because they're nearby? We do nothing. And there's no enforcement in the USA as a mandatory upgrading of our infrastructure of buildings, and neither for our infrastructure. So for maybe the highways, there's a program slowly, but I'm going to talk about later. So there's some exceptions, like in Los Angeles, and that was mentioned before, where mandatory upgrades are made for certain buildings. And there's very strict in their timelines to doing that. And I don't mean that we need to do an earthquake upgrading for all the United States, because there's no earthquake, well, we don't have to do that. But we have to do an upgrade on the structures itself. They're old. They are not forever. And people live in there, and people work in there. And that's our worst fear come together. For example, using as Los Angeles as a great example for mandatory upgrades, there was an approved, two ordinance were approved to take care of soft-story buildings and non-ductile buildings. In terms of earthquake, the soft story is a great peril. There's a lot of probability of failure. Those are buildings that on the first couple of floors, there's not too much stiffness, and then there's stiffness above those. So when the earthquake comes, it becomes like a pendulum, inverted pendulum, and the building shakes and it falls down. And we have had hundreds of those cases. And then the non-ductile buildings, older buildings made in concrete, probably prior to 1995, based on ACI codes. There was not enough reinforcement to provide ductility. And the ductility is an essence to earthquake resistance because it allows the building to go back and forth without really having failure. So these two ordinances, one of them take care of what to do with them, and the other ones gave the timeline of when to do it. Okay, so as you stated there, this was in 2015. This year and the beginning of the next, all these buildings must have been rebuilt already. That's the big pressure that was mounted on these two ordinances. And so the schedule is very aggressive one. It requires that a structural analysis must have been made to the structure 2 years after the ordinance. And then the owner had to have on record the necessary permits for repairing the structure or reinforcing the structure 3.5 years after the ordinance. And the job had to be completed in 7 years. Total time. It's not adding, it's the total time is 7 years. This seems great. Economically, in most of the United States, this is not feasible. It's a too much aggressive program because it's very easy to say, you have to reinforce your building. Your building is too old. We have improved the resistance, but someone has to pay for it. So personally, and that's what recommendations I'm going to talk about, we need to do it at a slower pace to allow for individuals, companies, housing projects to be able to raise the money. Because if we don't do anything like it's right now, our infrastructure of buildings will keep failing. If we start and it takes us 15 years, well, 15 years from now, we will have a resilient infrastructure. So we must start. So my proposed schedule is based on three things. First, it must apply to everything that is an essential facility, as defined by ASC 7 and IBC. And essential facilities are hospitals, police stations, general health facilities, schools, emergency management, etc. Then any structure that holds more than 300 people needs to be done. And finally, any infrastructure that requires, that services more than 50,000 people. We forgot about infrastructure because the only thing we remember about water is that we open and water comes out. Or we go to take a bath and we open it, water is out. There's a whole lot of infrastructure behind that water. So any facility that serves a lot of people needs to be rechecked every number of years and retrofitted because our lives depend on them. I was part of a committee evaluating vulnerability of Puerto Rico in a war. You only need 4 bombs. The 2 main dams and the 2 main power generator, and Puerto Rico is out. Nothing else works. You will live without water 60% of the population, and we'll have without electricity 90% of the population. And that's vulnerability. And that's the truth. We have to do not forget about infrastructure when we're talking about collapse or failures of infrastructure. So my proposed schedule for you guys is 5 years to submit the evaluation, 8 years to submit the design. That's accumulative. So, and 12 years to finance and finish the project. So a little bit longer than California, than Los Angeles. I think it's doable. You know, if you want to fight with me and we make it 15 out of 12, I don't fight. It's okay with me. Then we have resilient structure 15 years from now, but we must start. The difficult part is day one. When are we going to start reinforcing our structures? And in terms of maintenance and inspection, which has been discussed, I have a more aggressive view. That 40 years, I've been an engineer now for 44 years. And it's too long, 40 years. The structures deteriorated. There are structures that are in extraordinary form, but there are structures that in 5 years, they're having a lot of problems. And so how can the code predict that? No, it cannot predict it. So we have to have more regular inspections. So I think that the purpose should be to confirm that the structure is adequate for occupancy, whether it's for living or whether it's for having a party or whether it is for working. But we need a program to evaluate the adequacy of those structures. And that inspection should be to determine the general condition of the building. If that visual inspection raises a flag, then that opens another story. I've seen in the last 4 years in Puerto Rico, I have seen hundreds of structures because of the 2017 Maria hurricane and the 2020 earthquakes in the southwest of Puerto Rico. And structure will speak, particularly concrete. Concrete speaks more than steel structures. Steel structures are high, sometimes a little bit more their problem. But it really is in terms of Puerto Rico, and it's in Florida. We are in front of the sea. Doesn't matter you are 50 miles from the seashore, you're still in front of the sea. Hurricanes and winds are more larger than our streets and our buildings. You know, this is huge natural phenomena. And people, when they watch the news, they see the center of the hurricane. They say, oh, there is the hurricane. No, the hurricane is miles wide. And when it hit the coast of Florida, the pore water pressure on the sand, loose sands in the coast pressures the buildings and the under parkings and everything. It's a huge event. And wind doesn't take corners. It doesn't do like this. It hits like a man, and everything that goes beyond that is gone. And that's what we have to understand. So my recommendation is structural inspections every 10 years, maximum 10 years. Building owners must commence to perform repairs within a year of the engineer's report. If repairs are not executed within 2 years, the use permit should be revoked. And the use permit is really the only arm that the government has at the end to stop irresponsible owners. The use permit, well, you don't want to repair it, okay. Use permit is revoked, no one can use the building, whatever it was. And finally, the buildings have to have a mandatory reserve calculated on the type of building size. It has to exist. There's no way to all of a sudden have to do whatever millions repair. People have not, but if you, since the building started, keep accumulating money for the repairs, it can be done. It requires discipline to spend money where it's needed. It's for your own life safety. So that's my recommendations. And before we finish, I'm preventing collapses. And recently we have failures in Italy, failures in Europe, failures in Asia, failures in Latin America of infrastructure. And ASCE performs an evaluation every year. And the grade for the United States is C-. And that's an average. There's certain parts of the infrastructure that has a D. And that's where we go every day and go over the bridges and go on the highways, etc. So as engineers, not only for the buildings, we have to keep pushing the government that they have to assign money for infrastructure. Thank God there was some appropriation bill finally approved on infrastructure after 20 years of Republicans and Democrats scratching their eyes just to not get a political gain for a bill. While America is failing on infrastructure. No rapid trains, no super high-rise buildings. We are behind the world. And yet we spend trillions of dollars every year. So again, I could not finish without talking about that. Well, thank you very much.